Hello and welcome to the fourth lesson in the second session of our training. In this lesson, as you know, we are still expressing our algorithms in Python programming language, and that is what we are going to continue with. The previous lesson, that is lesson 3, as we stated clearly, we have 16 algorithms to express in this. But then we went ahead and then expressed 8 in our previous lesson. So in here, we're going to continue from the 9th down to the 16th, that is if time will permit us. So let's quickly dive right into it. Now the 9th algorithm says what? We should write a program to quarantine someone from China. For example, the program should take the person's name and country of origin as input. Program should then make a decision, that is if the person is from China, the program should display and say, hey, you are quarantined. But if the person is from any other country, the program should display and say, congratulations, you are free to go. So basically that is that. So let's go ahead and then express this right away. So I've already commented it and then wrote the title of the program, a program to quarantine someone from China or a person from China. So we take input first, right? So we declare name variable where the name is going to be stored. So we call on the input keyword. So we say what? Enter name. So the user enters the name. Then we declare another variable called country of origin. Then we assign it to the value, the input keyword here. We say enter country of origin. This user does that. And we're going to make a decision if country of origin equal, then there should be a string China, then print and tell them that hey, I want to concatenate, want the person's name to be mentioned, right? Hey, so and so, you are quarantined. Hey, so and so, you are free to go. So to do that, we're going to concatenate this. So say plus the variable name plus another string which says you are free to go. Else means if you're coming from any other country outside China, program should run print and say congratulate. Let me see. Now this should be congratulations. Sorry, you are not free to go, right? You are quarantined. So you say hey, so and so, you are quarantined, right? Else tell them congratulations. We want to concatenate with the variable name. So this should be a string. To go. Something like that stuff. Good. So we are done with our program. So we declare a variable called name where the name is going to be stored in whenever the user inputs any name at all. And then another variable called country of origin. Take the inputs going to be stored in there. So we are going to make decision using the country of origin. So we say if country of origin equal China, this is what comparison operator. We are comparing the country stored in this variable where the user input is from here to China. If it is from China, then the program should say, hey, so and so, Mensa, you are quarantined. Else means if it's from any other country aside China, say congratulations, Mensa, you are free to go. Or whatever name the user inputs there is going to be displayed. So let's run it and see. Name is what? Let's see. Hamis. Country is China. Hey Hamis, you are free to go. Sorry, you are quarantined. let's run it and make Hermes come from maybe, yes, Hermes again from Ghana. Hey Hermes, you are free to go. So you can try running it, entering any of the countries to check and see. So basically that is that. So I think there shouldn't be a problem. We enter the user's name, enter the country of origin. If the person is coming from China, then surely the person should be quarantined. Else, if the person is from any other country aside China, the person is what? Free to go. So basically that is that. You can try running it several times, test it just to enjoy a piece of art. So that is that. Let's look at the 10th algorithm, which says we have to write a basic calculator. Now what is a basic calculator? Very simple calculator which take going to be a very basic one, of course, and the calculator is going to take maybe two numbers, basically sum them, add them together, give results, multiply them if possible, divide, and then also, let's say, subtract. So basically that is how the calculator is going to be. It's like there was a similar one we implemented in a pseudocode in a flow chart. So let's try expressing it here again. So we are going to take input from a user. We don't know the number that is going to be calculating. We're going to take two numbers, so two inputs, and then the operator that is going to enter, whether plus, minus, multiplication or division, whichever the user enters, we need to take care of that. So we are taking three inputs from a user here. Let's jump right into it. So we're going to take the first number. So we're going to declare a variable called num1 or num1. So that will give us that is where the first number is going to be stored in. Then we're going to declare another variable called OPP, that is operator. Then whatever the operator the user enters is going to be stored inside it too as well. And then we declare another variable called num2, that is for the second number. So whatever the user enters is going to be stored in the second number. So basically that is that. And then after that we make decision on how we are going to arrive at the various answers or results. So basically that is that. Let's dive right into it. So a basic calculator, let's just write this. Basic calculator, good. So we're going to take input from a user. So we say num1, which is the first number, is equal to what? So since it's going to be a number, the person can choose to enter maybe 1.5, 1.8 or whatever. So we declare it as a float. So we call on the float function, then we call the input. We say enter first number. Then the user does that. Then we declare the variable called OPP, which means operator. Then we take input keyword. Input keyword. Then we say enter operator. Then the user does that. Then we call on the we declare the variable called num2, that is the second number. We're going to be a float. Then after that we call on the input keyword and you say enter second number, and the user does that as well. We're going to make a decision. We don't know the operator the user is going to enter, so we're going to take care of that using if statement. So if OPP, that's operator, equal to, let's say, plus, so going to be a string, then what should happen? Print should we declare variable called results, or we should just go ahead? Okay, print. Then we say num1 plus num2. So basically that is that. If the user enters operator, which is plus, it's going to sum up the number 1 and then the number 2 together and display the results. So what if the user didn't input plus? and is any other operator which we don't even know, so we take care of that as well. Say elif opp equal okay, elif opp operator equal let's say minus, then we say print num1 minus what, num2, and that will give us that one as well. Elif, please don't forget of the indentation. So after writing the first if statement and then you execute this, it executes this. So the next elif should come and then be in line with the if statement. So that is what we call indentation. So we shouldn't overlook it. It's very, very important. It can mess up your program if care is not taken. So elif opp operator equal let's say multiplication, right? It's going to be a string as well. Multiplication. Then what should we do? We say print say num1 we multiply by what, num2. So that is that. Another one, elif, what if it's not this and is division? Elif opp equal division, then we say print num1 divided by num2. Then finally it can happen that the user enters something which is not in any of the operators, and in that case we want to say value error. But these are the 4 basic operators we can use to add two numbers, subtract, multiply, and divide. So any other operator the person enters aside these 4, we want to tell the user that hey, value error, you've entered the wrong operator or whatever, something like that stuff. Good. So we want to print that as well. Print, so it's going to be a string, but invalid operator. So I think that is that. So first of all, we declare variable called first number, that is num1, and then we take input from the user, that is the first number. And after that, we declare another variable called opp, that is operator for short. We also took an input from a user, that is operator. And a third variable called num2, which is for the second number. Then so whatever the user enters from is going to be stored in these variables. So we are making decision here. So if opp, that is if operator, is plus, add the 2 numbers and then give us the results. If it is minus, subtract number 2 from number 1, this will give us the results. If it is multiplication, multiply them and give us the results. If it is division, divide them and give us the results. So basically that is how the program is. So let's run it and see. So the first number, let's say 78. Then we say operator, right? So plus, so say 10. Oh, okay, 88.0, because we declare them as a float, so it's taking them as float as it is. So 78 plus 10 is what, 88. So as you can see, the results here is what, perfect. Sorry for this, please. Sorry, just feeling stressed. So the results here is what, 88. Let's run it and change any other operator. So 5 is a multiplication by 5. So this gives us what, 25. So this is working perfectly. So as you can see, when the program is run, after taking the input, it checks this operator. If it is not this one, then it will check and get to what, the multiplication, and it will execute this block as we've explained in our first session. So this shouldn't be a problem. The way the program runs shouldn't be a problem. Why is this happening? Yes, this is because after running the program, it goes to the first line here and check, is the operator plus? If it is not, it wouldn't execute this one. Is it minus? If it is not, it wouldn't execute this one. Is it multiplication? If it is yes, then it's execute this one, then skip the rest. So basically that is that. Now you can try any other operator, but now let's try entering wrong thing and let's see wrong operator, and let's see what's the outcome of the program will be. Then I put let's say brackets, then 9. Oh, invalid operator. It means I've entered the wrong what operator. So the program should just prompt me and say I've entered the wrong or invalid operator, and for that matter I should beat at myself and enter the right operator. So basically that is that. You can run it over and over again, try it several times to see. So let's proceed to the next algorithm. Yeah, the next one is going to be an interesting one, of course. It's something like, as a developer or a programmer for maybe a company, and they want you to write a very simple program for them for checking something like this stuff. What is it? Say, oh, the price of a house is 1 million USD. If a buyer has a good credit, someone wants to buy, if the person has a good credit, then they need to put down something. That is 10% of the price of the property. That is 10% of what? The 1 million USD. Otherwise, else if they don't have enough credit, then they need to put down 20%. Because if you don't have money, how sure are we that you can pay the rest? So to be at the safer side, pay something which is a bit huge down before you can take the house, and then the rest you can do the payment later. So write a program to implement this rule. So basically that is that. So let's try writing it, and see how it's going to be. First of all, we are going to just declare the variable called price and assign it to the price of the house. So let's quickly check on that and then do that, or the price of the property. So we call this a house purchase program, right? Something like that. Good. So whenever the user comes in and then you want to check the details to confirm whether what the user has to pay before he can be given the property or she can be given the property, you don't have to sit and do some calculations. The program should take care of that for you, just to automate what you do, to make it automatic. You don't have to suffer calculating whatever it is and all that. You just know the requirement, you know what the inputs to take, and then make decisions with that. Good. So let's proceed and check. Let's proceed. Here we're not going to take any input from the user. We already know the price of the house, so we're going to check the details of the user. So it's like it's already programmed down. So you have a card which you have to maybe put into the system, and then what you have to do. If you have to pay 20%, the program tells you. If you have to pay 10%, the program. So when you put in you slot in your card like ATM card into the system, you just have to stand and wait for the program to get executed and display whatever it has for you. So basically that is that. So declare variable called price, set it to equal to what? Sorry, price is equal to, say, 1 million, right? 3, 4, 5, 6. Is it? Yeah, 1 million. That is that. 1, 2, 3, 4, 5, 6. Good. So now we are talking of if the user has a good credit, and then what? The person should make down payment of what? 10%. If the user has no good credit, means if you don't have enough money, then it means you have to make 20% of the down payment. So basically that is that. So let's go ahead and then check that. So we declare a variable called price, and then we set it to what? The price of the property. So here we're going to use the Boolean operator, that is a true or false, to be able to work out this. We learn about the Boolean, right? So let's see how it is expressed or implemented in Python. So we can say has declare variable called has good credit. Then we set it to equal to what? Equal to true. So initially we assume that the user has a good credit. So we assume that way. So if the user has that, then something should happen, right? We can equally take inputs and then make decision with it. But taking inputs here is becoming a bit boring stuff and all that. So you see it. So we just have to put it this way so that we know that in writing program, it is about logic, how the program works. If after writing it and then we run it and it's working perfectly the way we want, it doesn't matter how it is written, so far as the syntax is there, the logic is there, you are good to go. It's a program, you can do whatever you want with it. So we decided to write this one this way. So we assume that the person has a good credit. If the person hasn't gotten a good credit to the program will tell us at the long run. So let's proceed. So we say what has good credit is equal to true. We are setting the good credit is equal to true here because we assume the person has a good credit. So now let's check that. So if the user has good credits, if has good credits, then something should happen, right? What is that? Then we say down payment. We declare variable called down payment, what the person has to pay. So we say the down payment is equal to what? So we're going to multiply 0.1 by the price. That is what? 0.1 times 1 million, and that will give us a down payment the user has to pay. So that is 0.1 times 1 2 3 4 5 6. So if the user has a good so let me declare this variable. Okay, down payment. Let me just do this. I think that will be good for me. Good. So if the user has a very good credit, so if has good credit, then the down payment, what you have to pay is what? 10% of the price. So to get 10% of the price, you multiply 0.1 times the original price, that is 1 million. So else here means maybe it's assumed that you don't have good credit. So for that matter, down payments should be something like 0.2. So you should pay 20%, right? Times what? 1 2 3 4 5 6. So after that we print down payment, and then after that we say we display the down payment the user has to what? Pay. So we say print. So we are going to what? Should we concatenate it or use a format? Okay, we are going to concatenate, right? So let's do that. You have to pay down payment of what? So and so. So you are to pay, or you have to deposit something, 30% of the price, or 10% of the, or you have to deposit this amount. I don't know. So please, you can write something that the program should display for the user to see, right? You have to pay, or you have to do down payment, something like that. Down payment of so we're going to concatenate this, right, to what? Maybe down payment, something like this stuff. So you have to do down payment of what? The price here. Okay, here what is stored here is what? In fact a float, right? But then they say what? Expected type is a string. I got float instead. It is float. So you know what to do. We are going to use the str keyword to be able to get the best out of this. So we close this and then we are good to go. So the error is clear. So if the user has a good credit, now we know after running the program. So first of all, we declare a variable called price and then store the price, which we already know inside the variable. And we assume that the user has a good credit. So it has good credit is equal to what? True. So initially we assume the user has a good credit. So we are going to know here by making our decision. If has good credit, then down payment is equal to what? 0. That is 10% of what? The price. So to get 10% of the price, you multiply 0.1 times what? The price. Else if the user has what? That has low credit, so it means here will be false, and for that matter this will be executed. So it will say what? You have to, it will multiply 0.2, that is you have to pay 20% of what? The price of the property. So basically that is that. So the program will display and tell you what you have to do. So now let's run the program and see. Good. So what? You have to do down payment of what? That is 100,000. That is 10% of the price. Because why? You have a good credit. We set it to be what? True. So because here you say you have to do down payment of what? 100,000 Ghana cedis. That is 10% of what? The total price. That is what? 1 million. Sorry, 1 million USD. So basically that is that. Now let's set this to be false and let's see. Now when we run it, here we have to pay what? 20% of the price because we assume that you don't have what? Good credit. So let's run it and see. You have to what? Do down payment of what? 200,000. That is 20% of what? The original price. So basically that is that. We can equally take input from the user. That is the user's name and then the amount the user has. You can equally do that. I see taking inputs to be a bit boring. We have learned about booleans, so why don't you also write a program to express that so that we see how booleans to work. So you can see how booleans work here. So I think with this program too, we are done with it. So if you set it to be true once again and you run it, then it has to do down payment of what? 10%. That is what? 100,000 Ghana cedis. If you set it to false, the boolean should be in capitals, please. Sorry. You set it to false and you run it, the person has to do down payment of what? 20%. So basically, that is that the program is running perfectly and then there is no problem with that. So basically, that is that. So we proceed to the next program. So I have to write a simple program to take an input from a user. That is something like a name. If name is less than 3 characters, let the user know that the name must be at least 3 characters. Otherwise, if the name is more than 50 characters long, let the user know that the name must be or let the user know that name can be a maximum of what? 50 characters long and not more than 50. So that is, you can see this is a program which can be implemented or can be used when we are creating our passwords on some websites or writing usernames and all that. You can see at the point in time you create your password and it says it's too short. Password must be at least. So basically this is something like that. If you use a Python what do you call it, framework called Django to write a program, just write this. When you get to the creating of account section where you're going to design a form for creating an account and all that, so this program is going to be used over there to take care of what you're going to enter and what you want as a programmer. If you want the password length to be 3, you can decide to use this program to implement that. So whatever you want, you go ahead and then execute that. So now let's proceed and try working on the program to see. So let's proceed. So we have to first of all enter the name, declare a variable called name, and then then we say inputs. So we want to tell the user to what? Enter name. Say enter. Don't forget if it is a password as well, you're going to know what to do is password. So we're going to use the length function. The length function, what the length function does is that it counts the number of characters in a particular word or whatever. So we're going to use it. So we say if len, that is if the length of what? The names stored here. So into bracket the variable name is we are going to use is less than 3. So you can see what we are saying is that after the user enters the name, it's going to be stored here. If the length in the characters, if the number of characters in the name is what? Less than 3, now I want to tell the user something. Print. What should you say? Say name must be at least 3 characters long. So good. So you say name must be at least 3 characters long. Name must be at least 3 characters long. But what if the user enters something more than 3, maybe more than 50? We said if the user enters something more than 52, you tell the person that it must be at least 50. So we say elif length in the variable name is greater than 50. It means it's more than 50 characters. Then we want to print name must not be more than what? 50 characters. Name must not be, so you say what? Name must not be more than 50 characters, something like that. Good. So we say into brackets it's not be more than 50 characters, and basically that is that. So you say else. So if the user inputs something in between these two, but it's not less than 3 and it's not more than 50, then we want to tell the user that name looks good or something like that. Name looks good. So we say print bracket C. Name looks good. So basically that is that. Now let me explain the program once again. If the user enters the name is going to be stored here. So we declare variable called name and then call on the input keyword, and we took the name, whatever the user enters here, we're going to take it. So if the name is what, we want to use the length function to check the number of characters in the name. So if length into bracket name, if the number of characters in the name, this is what it's checking, that it's less than 3, we want to tell the user that name must be at least 3 characters long. At least means it shouldn't be less than 3. But what if the user enters something more than 50? We want to tell the user that, hey, name must not be more than 50 characters. But if the user inputs something in between from 3 to maybe 15 between that, or maybe from, yes. So we should tell the user that print something like this, name looks good. So now let's run the program and see. First of all, let's say the person's name is called Anne. Oh, say what? Name must be at least 3 characters long. Now let's enter 3 characters. You see, the Anne should be now 3. Name looks good. So let's enter something more than 50 and see. So random blah 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 blah. Typing nonsense is nice. It's very interesting sometimes. Let's run this and see. Name must not be more than 50 characters. You can see that it's more than 50 characters. So now let's try writing something a bit lengthy. James Rowe. I will separate it. Guys, blah blah blah. Name looks good. So perfectly it's working. Now we can choose to change this to what? Maybe password, right? Password. 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 So instead of name, we're going to use password keyword here. So enter password. So we say what? Let's see. Sorry. So let's change this to password must be at least. So this should be our password. Let's run it. So the first thing. This is still saying name. Sorry, here password. Run it once again. Password must be at least 3 characters long. So because it's short 2, so it's not working. Run it once again. Run it. It should tell us something like password must not be 50 characters. So we enter something like say 50 characters or more. Then we enter random things and all that. So when you run it, the password must not be more than 50 characters. So basically that is how the program here works. So I think it's working. So you can try running it over and over and over again until you get to realize that in fact the program is working. So you can twist it anyhow you want. Like I said, when you use a Python framework called Django to create a website, when you get to the login section or account creating section, you want to take care of the number of characters you need in your username and password and email address and all that. This simple program can be written and then implemented over there. So you'll be good to go. So that is that. We are done with this program. Let's look at the next program on the list. Yeah, our next algorithm on the list is we have to write a program which will enable the user to input their weights in either pounds or kilogram, and then you convert it to other units. So initially we wrote a program where we take input from the user, that is a number or weight in kilogram, then we convert it to what, pounds. And we wrote another one where we take it in pounds and convert it into what, kilograms. So in this particular program we're going to embed the two. So when the user enters a number, first of all we take a number as input from the user, which is the weight. Then we prompt the user to tell us whether what the user has entered is in pounds or kilograms. If it is in pounds, then we take it and convert it to what, kilograms. If what the user enters, the user says is what, is in kilograms, then we take it and convert it back to what, pounds, in the same program. So let's see how it's going to be. So first of all we declare a variable called weight. Say weight. Then we assign it to the input we're going to take from the user. So it's going to be a float. Sorry, float. Then into bracket we call on the input keyword. Sorry. Then into bracket we call on the input keyword. Then we prompt the user to say enter weight. Then we say in either that is we say LBS, which is for pounds, LBS or kg, in either pounds or in kilograms. That is the first line of code. The second one, we declare a variable called unit. This is what will prompt the user to tell us the unit in which the user enters the number for. With this line of code, it prompts the user to tell us whether it's in what, pounds or kilograms. So we use two different letters to take care of that. If the user types in L, it means it's in pounds, and for that matter we convert it to what, kilograms. If the user enters K, it means it's in kilograms, so we convert it back to what, pounds. So that is how it's going to be. So we say input, call on the input keyword, then a string, let me say L into brackets LBS. So this is what the user enters here, that is if it is in pounds, or say K if it is in kilograms. The user enters this. Good, so we are good to go. So something like this. So we prompt the user, we ask the user, what have you entered? What you have entered, what is it for? Is it in kilograms or in pounds? The user enters any of these letters to tell us what it is for. So now we are going to make a decision after taking the input from the user, right? So that is that. We say what, if units dot upper, I will explain this dot upper, what do you call it, a function for you, dot upper, that is equal, that is a assignment operator, right? Sorry, comparison operator, right? Equal key. Now what this line of code does is that, let me terminate it here. Good. Now what this line of code does is that we are saying that if unit dot upper, if the unit the user enters here is K, which is in kilograms. Why this dot upper operator here? What it does is that it takes care of the letter the user inputs here. If the user inputs capital K, it takes care of that. If the user enters small k, it takes care of that. If the user enters capital L, which is in pounds, it takes care of that. If the user enters small l, it takes care of that. So without this dot upper, and we declare this as what, capital K, then the program is what, restricted to only take capital K. So for that matter, if you enter small k, there will be an error because we didn't declare that. But with this dot upper, it's able to take care of both small letters and then capital letters. So whatever the user inputs here, whether it's in small, whether it's in lowercase or uppercase, it takes care of that without any issue. So basically that is that. So we say what, we declare another variable called converted weight. Converted weights is equal to, so if the user enters in kilograms, what we are going to do is what, we multiply the weight by what, 0.45 to give us in pounds. So we say converted weight equal to weight. Where is the weight coming from? The weight variable here. Whatever the user inputs here is what we are taking here, to be multiplied by 0.45. So basically that is that. Then we say what, print. Then we print what do you call it, and tell the user that your converted weight is, then we tell the user what the converted weight is. So we see your converted weight is, so something like this. Terminate it. So we're going to concatenate it to the converted weight. But then you know the converted weight here is a float, right? And we don't concatenate float to string, so we have to use the str function, a string function, to deceive Python that it is actually a string, yet we know that it's not a string. I hope you understand that. So it's a converted weight. So that is that. So since we are converting it from what, kilograms to pounds, so we say what, so and so, then we say plus. So we use whether pounds or okay, lbs, which means this should be a string, lbs. So when we run it, this will what, print your converted weight is maybe 0. whatever lbs, it means 0. whatever in pounds. So that is that. Elif, let me just we say elif, which means else if. Let me bring it down a bit. Else if what the user enters, so it's a unit, you call the unit dot upper operator again. Unit dot upper equal what do you call it, key. So the first one, okay, we can interchange them, right? The first one we use, okay, if that is the case, we are not going to multiply here, we are going to rather what do you call it, divide. Sorry, so we say divide, sorry, divide by this. We divide the weight, since we are converting from what do you call it, kilograms to pounds, we divide what do you call it, the weight by 0.45. and here, so if unit dot upper, whatever the user enters is in what, let's say L, which means it's in pounds, then we terminate it here like this. Then we say declare another variable called converted weight, sorry, weight equal to weight. As usual, you take the weight again, sorry, then we now multiply it by what, 0.45. then we print this. So we can just, okay, I don't want to copy it, so we say, sorry, your converted weight is then this. I'm going to concatenate it to what, str. I hope by now you understand what this is all about. Converted weight plus this should be a string, kg, sorry, kg. Good. Then I think we are done. Then we say else. Let me finish and then explain this. Then we say else, print else if the user enters any letter aside either K or L, which we know is in either pounds or kilograms, then we tell the user something. The program shouldn't throw an error. We should tell the user something like invalid units or unit unknown. Okay, say invalid units. So basically that is that. So if the user enters maybe A or B or any other letter aside our assigned letters, which is K and L, it doesn't throw an error, but rather it tells the user what, invalid unit. So that is that. So let's go over the codes again. So we declare a variable called weight, which it's going to be a float, right? So yeah, say enter weight. So this prompt the user to enter weight. So whatever the user enters here, we don't know whether it's in pounds or it's in kilograms. For that matter, we declare another variable called units to find out the unit in which the user enters. If the user enters L, so we use L to be what, for pounds, that's lbs, or K to be for kilograms. So if the user enters, so we say here as what, if unit dot upper, if what the user enters here equal, this is what, comparison operator, equal K, it means whatever the user enters here is in what, kilograms. So we convert it to what, to pounds. So we take we declare another variable called converted weight, then we assign it equal to what, then we take the weight and divide it by 0.45. That is how we convert weight from kilograms to pounds. And then we print the results and say your converted weight is plus a string here. We are concatenating this to what? Our converted weight, which is a float. But since we don't concatenate float to a string, we use the str function to what? Convert this to what? A string. Yet we know that it is carrying a float. And we then concatenate it to what? LBS. So this will print a number LBS, which means so and so, maybe 0.5723 pounds or LBS or whatever. And then the same thing, let me just explain this dot upper function again. What it does is that if the user enters either capital K or small k, here too, the user enters whether capital L or small l, with this dot upper operator, it should take both. But without it, what it means is that the letter we assign here is what the program is restricted to take. Which means if it is capital L, it's solely for capital L. If you enter small l, the program throws an error. So we don't want that, because we don't know what is in the user's mind. L is L. It doesn't matter whether it's capital or small. So whichever the user enters, it should be able to work, provided it is the letter in question. So that is that. So here too, if the user enters L after entering the inputs, the user is telling us that what he has entered is in what? Is in pounds, and for that matter, we should convert it to what? Kilograms. So to do that, we declare another variable called converted weight, then we assign it equal to weight, then we multiply by 0.45. And that is how we convert weight from pounds to what? Kilograms and all that. So after that, we say print your converted weight is so and so and blah blah. So let's run it and see. Oh, sorry. Let me just stop this and choose a different app here. Okay, I'm using this. Good. Let's run it now. So we have to enter weight. So let me just enter 50. So they are asking me, is it in LBS or kg, whether it's in kilograms or it's in. So let me just type K, which means it's in kilograms. So so it says what? Your converted weight is 111.111 LBS. So it has been converted from what? Kilogram to weight. To pounds. So I'm going to enter this 111.111 again and say it's in pounds. Then we see what is going to be converted it into. Let's run it again. So I'm going to input 111.11111. So this is in pounds, right? So I type L. So here you can see I've just typed small l. So it says what? My converted weight is what? 49.99, which means when we convert it, we round it to what? A whole number, whatever. It's going to be 50 kilograms, which means it's just working. So the program is working perfectly without an issue. So you can try it over and over again, entering numbers and all that. So that is that. Let's move on straight to our next algorithm. Now, next algorithm, that is the fourth thing. We have to write a simple guessing game. This program is going to help us understand how loops and the for loop and then the while loop and all that, how they work. So let's dive right into it. Good. I have nothing to run with again. So simple guessing game. Now let's proceed. What's going to happen is this: we're going to get a secret number. Then we prompt the user to guess the secret number for some number of times. As we talk of loops, as the user guess, we have the number of times the user guess. So with this, when the user is able to guess within this range, and there's still time for the user to guess, then we say the user has what? Guess correctly. If the user is not able to guess within the number of times given and the time elapses, then the user loses the game and all that. So to do that, we declare a variable called secret word, and then we store the secret word inside the variable. So let's do that. So we say secret word. Then we assign it equal to what? Let's see, the secret word should be king. Okay, so that is our secret word. This is the word we want the user to guess. So we declare another variable called guess. And here we're going to set it to what? An empty string. Sorry. We're going to set it to what? An empty string. Oh, sorry, what is happening? An empty string here. So you see this. Why an empty string? Because initially the user hasn't guessed anything. The user hasn't started guessing. So that is why we declare it as what? An empty string. So the next variable is going to be say guess count. And that is what is going to that is what we term as the counter variable when we were doing the programming techniques. So we declare our counter, initialize our counter variable. So it's a guess count. So we declare variable for it. It's a guess count is equal to 0. Initially, the user hasn't guessed anything. So the guess count as at that moment is 0. So we declare another variable called guess limit. Guess limit, then we assign it equal to what? Maybe the number of times you want the user to guess. So we say 3 times, right? Okay, whatever number you want, you can still have to. So we declare another variable called out of guess, and now we are going to use a boolean for it. I'll explain that. So we declare another variable called out of guess. Then we declare another variable called, so which is equal to what? False. Why out of guess is false? Because initially the user hasn't guessed. Since you haven't guessed, it means you are not out of guess, and for that matter, out of guess is what? False. If you are out of guess, then this should be true, which means you are out of guess. We talk of what? Boolean, so this shouldn't be a problem again. Out of guess is also another variable we have just declared, which is telling the program that the out of guess means it's either you are out of guess or you are not out of guess. If out of guess is set to false, it means you still can guess. If it is set to true, it means you are out of guess, and for that matter, you can't guess. So that is a boolean. So in this program, we're going to combine a lot of things: while loop, the boolean, then the if statement, and then we see how the program will work for us. So let's proceed. Now we're going to make a decision using the while loop. So we say while. It means as long as your guess. So we wrote a pseudocode for this, right? So don't forget. Your guess is not equal to, this sign means it's not equal to, right? It's not equal to what? The secret word. And now I'll explain this. And not out of guess. Let me explain what is happening here. So let's terminate it first before. What we are saying is that as long as your guess here, the guess you're going to enter here, is not equal to the secret word which we are looking for, and then you are also not, and not, the and not operator means and not, it means and you are not out of guess. You can see how the program works. It's just the same as the human readable, but just that it's a bit different. So grammatically this should read, or maybe in our normal English language, this should read like, as long as your guess is not equal to the secret word, you are not out of guess, and you are not out of guess. But in programming language like Python, this is how it reads. While, we use the while, not as long as. So while guess, your guess is not equal to the secret word and not out of guess, and then you are also not out of guess, then it means you can still do what? Guess, right? So that is the first one. So we make decision here as well after this. So we say if the guess count. So this, okay, the guess, let me just choose this, sorry, guess count is less than guess limits, right? Terminate it here like this. Now what we are saying right now is this. The first line here says what? As long as your guess here, the guess you've entered here, when we run the program, whatever you want to type, it's not equal to the secret word here that we want, and you are also not out of guess. That is the first one. And also another decision here, if the guess count here is still less than what? Guess limit is less than this one, initially it's still less than this, so it means you can still guess. These are the two conditions that will allow you to still guess. If these two conditions are still false, it means you will still continue to guess. So at this moment they are false, at this moment they are false, so you can still guess. So let's tell the user to guess again. So we say guess, declare another variable for guess, then we say equal to, we say input, we prompt the user to what? Enter guess, right? Then we say enter guess, then we say enter guess. Good. So the user will what? Enter guess here again. So when the user enters the guess, so we are going to do something here. We will begin counting the number of times the user does that. So we now begin to add our what? Counter variable. So we say what? Then guess plus equal to 1. So what it means is this: if there is, with this condition still false, whenever the user enters guess, then we add it to the previous guess, and that is what is going to be what is counting the number of times the user is going to guess. And as it's counting, it is having this in mind. The moment it gets to this, it means the user is what, out of guess. So let's proceed and look at that. So we say what, else, and please, this is where indentation comes in here. If it's not well done, it means your program will throw an error. Now what we are doing here is this. So you can see that the if is in line with what else. That is what we term as indentation. It should always be like that. So you can see this while is also having its what, terminator. So I'll be bringing it very soon, and then it will also match with it. So that is how it's going to be. So what we are saying is this. As long as our guess is not equal to secret word and you are not out of guess, that is the first condition. So it's false. If guess count is less than guess limits, which is also false, as long as these two are false, then you have to guess. So when you guess, then we take your guess and then count it. As we count, we add it to this 0, and then we increment it until we get to this. Else means if this condition is false, it's still false. Else, then we say out of guess is equal to what, true. Is equal to true. If these two conditions are not met, like if you are out of, initially they are false. They are false because you are not out of guess, and then you didn't get the secret word, right? So you can still guess. And then also the guess count is also less than guess limit. So for that matter, they are true. If they are not true, then we say what? Then out of guess. Then this one is what? If they are false at that moment, and then you are out of guess, then we say what? Then out of guess is equal to what? True, which means you are out of guess. And that is when the guess count is what? Greater than the guess limit or equal to it. That is when this guess count is equal to or greater than this one. That means you are what? Out of guess. So if guess count is less than guess limit, you can still guess. Else, you are out of guess. Else means if it is not less than, then it's greater than, and if it is greater than, it means you are out of guess. So we say what? Out of guess is equal to what? True. So that is that. And so we're going to make another decision here again. So we say if out of guess, if you are out of guess, then want to tell the user something. So we say print out of guess, you lose, right? So we say out of, or we say you are out of guess. You are out of guess, comma, or whatever, comma, you lose. Sorry. You can say try again next time. Something, sorry, next time, right? Next time. So we tell the user this. That means the user is what? Got them out of guess. So and then we say else. Else means maybe you are not out of guess, and for that matter, you are able to get the secret word, right? So we say print hooray, you are a genius. Got something like that, whatever. So let's go over the lines of code once again. So it's a simple guessing game, right? This is how games are written. I told you these loops are normally used in games, not only in games, they are also used in other programs as well, but mostly in games where we deal with counting and all that. So it's a secret word. We declare a variable called secret word. We set it to what? King. So that's the secret word we want. We say guess is set to what? An empty string. This is an empty string. The two inverted commas with nothing in between is what? An empty string. Guess counts, the way we're going to be counting the guess. So we initialize it to what? 0. Initially it's 0 because the user hasn't guessed anything. Guess limit is set to 3. You have only 3 attempts to guess. Out of guess is set to false. It means you are not out of guess. So as long as, so we say while guess is not equal to secret word and not out of guess, it means as long as you are able to get the secret word and then you are also not out of guess. That is the first condition, which is false. If guess count is less than guess limit, if this is less than this, as you can see, it's still less than it, that is what we are guessing, then it means you can equally guess again to a guess. So when you guess, we take the guess and then we add 1 to the previous guess and then we sum it up and we compare it to this. So we add 1. So when you get the first time is 1, you get second time is 2, you get the third time 3, and then you didn't get the secret word, means you are out of guess. So if this condition is normal, then it means you are out of guess. So we say out of guess is equal to what? True. So, and if out of guess, what should happen? You say what? If out of guess, then we need to tell you that you are out of guess. You lose, try again next time. Else means if you are not out of guess, then it means what? You have gotten the secret word, and then you haven't, the guess count is still what? Less than guess limit. So you say what? Print, hooray, you are a genius. So it's something like, so let's run it and try it and see. So we say guess. So let me check something here. Yes, make it a bit. Enter guess, right? So something like this. Enter guess. So that when we run it, you can have a space here to stop it and run it again. Good. So enter guess, right? So we say king. Oh, it throws an error, right? So what is the problem? Can only concatenate string. So which line is it? So line 14. So let's trace it and check where the problem is coming from. Line 14 in module guess plus equal to 1, right? Okay, this is okay, it's a guess count. This should be a guess count. Sorry. Good. Guess count here. I think the program should work for us now, right? Let's try it again and see. Now what happened was that I should be incrementing the guess count, which we set to 0 rather. So you see, guess count is set to 0. So we need to be adding 1 to it as long as the user keep guessing. So that is where the problem is coming from. So we can say hooray, I won, right? So it's correct because I just entered it correctly. So let's try running it and then entering different things. So you see how it's going to be. So the first one I didn't get it correct. So second time I didn't get. So I'm to guess the last time again. So guess again. Oh, I'm out of guess. I've lost. So that means I've exhausted the number of times I need to guess. So let's check something here. Now, what if the user enters them in capital letters? Let's also happen. They say I should guess again. It means I didn't get it correct, and I'll tell you why. So I'm out of guess. I've lost. Yes, what I've just typed is king, right? So let's check here. That is because here what we are taking is just what? Lowercase. So if you want, if you want to what? The program to take care of both lower and upper, or even both in combining or combination of both, then we need to use what? The dot lower operator, right? So we say dot lower operator. Sorry, dot lower, something like this. Now, what is the difference between dot lower and dot upper? Here we are taking what? Lowercase letters. So if we want it to be able to take care of what? Both lower and upper, we use what? Dot upper. But if we set here to take what? Uppercase, and we need to take care of both upper and lower, we set it to what? Dot upper. If it is lower here we are taking, we set it to dot lower because we need to take upper as well. It is just the vice versa. Sometimes you think like, if here is lower, then this should be dot upper so that you can take care of dot upper, right? No, it is not your language. This is Python programming language. It doesn't work like that. This one, sorry for that. This doesn't work like that. If here is lower and you want to take care of upper, you tell the program that dot lower. It means it should take care of what? Upper as well. So that is that. So with this, let's run it over again and see. So now let's take the upper. Sorry, king. So hooray, I won. So now the program is working perfectly. So you can go over it again, try it several times, check and check and check, and then you'll be good to go. You can try it, change your secret word, and then from there you're good to go. So basically that is that. Let's look at the next algorithm. The next algorithm is that we have to program a simulation of a car engine, right? So program a simple car engine. The engine should be able to take these commands and execute them accordingly. So it's a help to display all the features of the engine with what they do. We didn't write a pseudocode and even draw a flowchart for this, but we're going to write it here, right? So let's do that. So what? Program a simple car simulation. Is this a simulation of a car engine, right? So it's when you type help, so there should be something like control buttons in the car. When you press help, then this information is displayed. Displays something like, it displays the features of the engine with what they do. So it displays something like this. start, it means to start the car. Stop, it means to stop the car. Quit, it means to quit the car. So it means that when you press start, you have to start the car. If you press stop, you have to stop the car. If you press quit, you have to exit the program. So basically that is that. And then after that, when we are done, we are to improve the above car engine a bit. For example, if you type start and the car is already started, it should not be able to receive the same results when you press the start car engine again. Okay, well, what the question here is saying is that after the car has started, something that has started already, do you have to start it again? No. So we have to improve it. So let's see how that all this is going to work. So let's check it out. See. So let's clear all this signature. Done with that. So what's going to happen here is this: we're going to declare a variable and set it to empty string, and the variable is going to be the commands, like the control buttons, or you can say control button or the control button. So let's say okay, commands, something like that. So it's commands or command is equal to, so we set it to what? Empty string. Initially you haven't issued any command. Now we're going to use a while loop in this program again. A while loop. We can use if statement as well, and we can use the combination of both. So let's do that. Let's try using the combination of both. So we say while. I will explain this. True. Now we're going to test the condition here first. So let's terminate. This error pops up because we didn't terminate it. So we use the colon to terminate the program. We use colon to terminate if statement and then the loops. So that is that. While what is true, while this command, which is set to as what? Empty string, as long as it remains true like this, something should happen. We need to prompt the user. So for now it is true, so nothing is happening. And if it is true, we need to do something. What should we do? We need to prompt you to enter a command. So we say command is equal to what? So we say input. Then we say we give you something like a prompt, right? So we say something like this. Okay, so this will give you the chance to what? Input. Let me see, why is this command? Why typing it wrong? Let me check here. Redeclare command. Define above without usage. Have I spelled it correctly or wrongly? Let me see. Command is equal to empty string. Good. This is because we set it to empty string. Let's proceed and see what's going to happen. Now, the command we're going to take here for now, at the start, is going to be taken as what? Lowercase. So we need to take care of what? The uppercase, right? So we say dot lower. So that is that. So when you begin typing, you'll be prompted to autofill it, right? So something like that. So now we need to make a decision. If command is equal to, what the user enters here, if command is equal to something like let's say help. If command is equal to something like this, then we need to what? Do something, right? We need to print some statements. Now here we're going to print some series of statements. Start means to start the car. It's going to display something like the instruction. So just press the shift button and then you press the, what do you call it, the inverted commas key 3 times, right? Something like this, 3 times, then you hit enter. So we're going to type in between them like this. So we give a space. So give a space here. So we're going to type in between. I repeat this instruction again, please. Let's do it well, so it doesn't give us issues. So into bracket, after issuing your or typing your print statement or a print function, press and hold the shift key, then you press the inverted commas 3 times, because we're going to write 3 different lines of what? Strings. So that is why it's what? 3 times. So you press shift 1 2 3, then after that you press enter to give a space to move the other one to the next line. Then you press this and then you get this particular. So with this we can then type our commands here. So we say start means is equal to, okay, we don't use the equal sign here. So it means you have to start the car. So we display the instructions, right? Start the car. So what is going to happen here is this: if the user press start, so if the user types help, it will display the instruction. We all know what help do in our programs. If you don't know how to use a program, there should be a help button. You click on the help button and you see the instructions on how to use the program. So that is what we are doing now. We are designing a simulation of a car engine, like those toys car, you see them, then we say they are programmed. How are they programmed? Well, this is how they are programmed. So we are programming something like that. So let's continue. So we assume that we have something like knobs. I should have drawn something like that using a paint or something, but then you couldn't do that. You should be able to do that yourself. So you can just go to paint and draw something like a rectangle. Then you draw 4 different buttons. One is for help, one is for start, one is for stop, one is for quit. If you press whichever, then the output comes. If you press whichever, then the action is taken. So that is that. If the user types in or press the help button, it displays the help features. So you say quit, stop means stop the car. If you press stop, it means the car should be stopped, right? Something like that. Then if you press quit, means exit. You have to exit the program. So that is that. So basically that is that. If you press the help button, this is what we want to display. But what if I didn't press the help button? It means I already know how to use the program. So that is when the elif comes in. If I didn't press the help button, it means I'll press something. So let's take the elif, the command. Elif, I didn't press the help button, I press a different command, which is equal to, let's say, maybe something like starts. And if the command I press is start, then something should happen. Then it should print and tell me that car started and ready to go. Watch. So something like this, car started and ready to go. So that is, if I press start, it means the car has started. It should go now. So what if I didn't press start? So elif again, making different decisions. So elif command equal maybe something like stop, right? Yeah, something like stop. So that's the next stop. Sorry. Then we say what? Print. Then we say car stopped. That means the car has what? Stopped. So say car stopped. Good. Elif, let me just elif command equal to, let's say, quit. If I type quit or I press the quit button, then the car should what? I should what? Exit the program. Everything should stop. So we use the break function to do that. So break. If you press quit, it's going to what? Stop the program. It means it's going to stop the car. You are out of the control. You are out of controls. It means you can't do anything again at that moment unless you start the actions again. Unless you start pressing one of the keys again. That is when maybe if you press start again, that is when the car starts. So that is that. So let's proceed. Else. So we say else. Else means aside this particular helps. If you press any other help. If you press, aside these particular functions like the help, the start, stop, and quit, if you give any other instruction, the program should tell you something, right? Something like, I don't understand this command. Very good. So print. So I don't understand this command. So that is what we want the program to do for us. So let's go over the lines of codes again for more understanding or for better understanding. So like I said, a simulation of a car engine, something like a car engine, where we see kids have their cars. When they press something, then the car moves, and then they do that, and then you say, hey, the car is programmed to do that, right? How is it programmed? You are now understanding it the better way. So from now onwards, if you see something like it, you shouldn't be surprised again. You can equally do the same thing in the near future, if not now. Good. So we say what? As long as, so we said command is equal to what? Empty string, which means nothing has been done yet. So we say while true, as long as nothing is done, we want something to be done. Then what is that? So we want to prompt the user to enter a command. So command is equal to input, enter a command. So the dot lower function here is able to take care of both upper and lower case letters, or the combination of both here. if command the user enter is what help, wants the program to display the help features of the engine. So it says what start the car, stop the car, quit, exit. And if the user didn't enter help, but the user enters something like start, then the car should start and be ready to go. But since we can't see the car starting, we need to tell the user that car started and ready to go. That is the function of the start. And if the user didn't enter the start and he enters what stop, then we should tell the user that hey, car stopped, something like that. And if the user didn't enter stop, didn't enter start, didn't enter help, then he enters quit, and we need to stop everything and jump out of the program to quit. So we introduce the break function here to stop everything. Else means if the user enters anything aside the 4 commands above, tell the user that I don't understand this goddamn program. So let's run it and see how it's going to be. So this is our arrow prompting us to do something. So let's type help. Good. So it displays the help instruction. Say start means start the car, stop means stop the car, quit means exit, right? So let's type something like start. So car started and ready to go. Let's type stop. Car stopped. Let's type quit. So we are out of the program. So it's working perfectly. So this should be like, so this is going to be programmed into a hardware where if you press what? The button, then maybe if you press the help button, then this one pops up on the screen for the user to see what the program, the function of the various commands are for. Then if you press start, then the car should start to go. It should be a hardware component, right? Something like a small car, and then it's programmed like that. And we also talk of how the machine is able to understand this. So you and I know that these are human readable words. So it means that the compiler here or the interpreter does take these lines of code and then translate them into what? Zeros and ones, right? That is to the hardware level. So with that, when these commands are issued on the hardware system, you should be able to work. You should be able to do what? Work perfectly without any issue. So that is how it is. Someone is making me laugh. Sorry for that. So that is that. Thank you. So now let's check it again. Let's check it again. Let's run it over again. So we say okay, start. Let's say start. So let's type it in capital letters. So start. Good. Car started, because we are able to take care of that, and you know what is happening in the code. So you know where that thing has been taken care of. So car started. So when I start, it says stop. The car stopped. It quits. And we are out of the program. So now let's check the next question. What does the question say? So improve the car engine a bit. For example, if you type start, the car started, you should not be able to receive the same. Okay. I'm sure you are getting the argument here, right? Now, what is going to happen here is this. It's going to be another tag of war for us here, but let's see how we can figure that out. It's going to be a very challenging stuff here, right? Improve the car engine a bit. For example, if you type start, okay, now what is going to happen is this. You can see that let's check something here. If I type start, car started and ready to go. Let's type start again and see. Sorry. Very good. So this is what the question is talking about. If you start the car and the car is going, do you have to start something that has already been started? No, you don't do that. So we don't have to take this instruction again. So what we need to do is that if you press start and the car starts, and then the program display car started and ready to go. When we press the start again, we need the program to tell us what? Car started. Car already started. Have you seen it? So you can't start the car again. So this is where the catch is. If you press start and the car is already started, are you getting it? And then you decide to press the start again. The program will tell you that car already started, and then it cannot start again. If you press stop, okay, let's go to stop. Car stopped. So stop again. Car stopped. The program shouldn't work like this. If you press stop once and the car stops, if you press stop again, the program is telling you that car already stopped. So something like that stuff. So let's check how we can figure that out. But to do that, we need to declare a variable and set it to a boolean. So, and the reason why this is happening is this: the moment you type in the start command, it means the car has already started. So, and the moment you type in stop, since the car has already started, it will stop. But if you bring in the start again, it will tell you car started. If you type start again, it will still tell you car started and ready to go. It will just be giving you the same what do you call it, a command again, instruction again. That is for the start. Like if you press start or you type start, you hit enter, it says car started and ready to go. If you press start again, it is telling you the same thing, which shouldn't be so, right? Yeah, it shouldn't be like that. At least it should tell you that car already started and then it can't start anymore. So we need to set a variable, declare a variable called started, and set it to false. So initially the car hasn't started. And even if it is started and you press stop and you start it again, it should start. If you start it and you restart it again, it should tell you that car already started. So let's declare a variable called started. Started is equal to, so we set it to what? False. So initially the car hasn't what started, so it's false. So we proceed and say what we come to after the start command. After the start command, we come to say here and make another decision again, right? Yeah, we make another decision here again. If command is start and if command is equal to start, then so what if, so we say if started, sorry, if started, it means if the car is already what started, then something should happen. Then what should happen? If started, we declare started to what? False, right? If started, then we want to tell the user that print. So sorry, car already started and cannot start again. Good. So that is how it should be. If it started, then if command is equal to start, then tell them that car started and ready to go. If it started, and tell them that the car is already, if it started and you decide to press start again, it should tell you this. Now let's take care of what they call it. Then after if statement, else must come, and you say else, then if this didn't happen, then it means started is equal to what? True. Though, say started is equal to what? Let's say true. I'll explain this for better understanding. Started is equal to true. Then for that matter, it should tell you that print something like sorry, car started and ready to go. So in short, if command is start, it should tell you that car started and ready to go. And if it's already started, that is where the if started comes. If it's already started, if started means in our normal language, if it's already started, then tell them car already started and then ready to go. Else, started is equal to true. Else, it means it's not started. And for that matter, tell them car started and ready to go, just as the first instruction. So that is what it means here. So now let's move to and check on how to deal with the stop issue, right? So we come under a leave command is equal to stop. So under this, so under the stop, then we're going to let's say no, we can't do that here. Let's check here. So before we go ahead and execute this stop, we need to check and see if the car is already started, right? Good. Yes. Before we tell the user this, maybe before we execute the stop function, we need to check and see if the car is already started. So that is when we can what? Execute the stop function. So here we say if not started, hey, there is something here. if not started, then we want to tell the user something. So we say what? Don't worry, I'll explain. Then we say print car started and ready to go. And ready to go. So we say what? If not started. Before we can execute the stop command, we need to check and make sure that the car is not what? Started. And at that moment it stopped. So from there we tell the user that car started and then ready to go. Sometimes programming, when things like this are explained to you, you think it should be like this or like that. Well, that is not how it works. It looks a bit awkward, but if you go deeper into it, you understand how things like this work. This is just the beginning. So I think as time goes on, you'll be able to understand them perfectly. Initially, I suffered than some of you are doing right now. But as it stands now, what I'm doing right now, I understand what is going on. I pray you should also understand. So we say, before we go ahead and execute the stop command, we need to check and make sure that the car is not started. And then before that, so if not started, then it means the car is stopped. So we tell them that the car started and then ready to go. So that is when we can stop it. If it started and ready to go, then we can stop it, right? So that is that. So we proceed. Sorry, car is already stopped rather. So like I said, before we can execute this stop command, we need to check that the car is what? It's not started. So if it's not started, it means it's stopped, isn't it? If the car is not started, it means it's stopped. So if that happens and the person press the stop button again, then we need to tell the user that car is already stopped. So we just do that, car is already stopped, something like that. Very good. So why is this print statement giving me error here? Okay, indentation. Good. I think this should be okay now. Good. That is one thing about indentation, because I've not indented it, that is why it's giving me this error. So like I said, before we can execute the stop command, we need to check and make sure that the car is what? It's not started. If it's not started, it means it's stopped, right? So we tell the user that car is already stopped, and for that matter, you can't stop it again. So we say car is already stopped. So we say and can't be stopped again, something like this. Good. So if not started, it means it's stopped. So you say the car is already stopped and can't be stopped again. So else anytime if comes, else must come, right? So else started is false. It means it's not started, so we can stop the car. So we say car stop, else started is equal to what? False. False. So we tell the user that print the car stopped, because at that moment you can stop the car now because it's not stopped. Good. Or car stopped, something like this. Good. And then I think it should work now. So let me go over the codes again where I've just made the adjustments. So the program initially was doing some styles, like when you start it and you press start again, then it's starting all over again. If you stop it and you press stop again, then it's stopping again, which shouldn't be so. Something that is stopped can be stopped again. Something that has already started can be started again. So that is how it should be. So we need to take care of that. So initially we declare variable called started and we set it to false so that we can be manipulating it in our program. So it's a boolean, right? Boolean. So let's come here and check. So we say what? If the user entered the start command, tell the user that car started and ready to go. And if it started, you can't start it again. And for that matter, say what? If started, we can't start. So we say what? Car already started and cannot start again. So simple as that. Else started is equal to what? True. And we say what? Car started and ready to go. So it means if it's not started and you press start, it should tell you that car started and ready to go. But if you already press start and you press start again, it should tell you this. So that is that. And if the command is equal to stop, if you press the stop command, before it can execute the stop command, it has to check something. What is it checking? It's going to check if the car is started or not started. If it's started, it should stop. But if it's not started, it means it's stopped, and for that matter can be stopped. So it checks and say what? If not started, then it means it's stopped, right? Good. Before it can execute the stop, it needs to check that is what is started. That is when the stop can work. If it's already started, that is when you can stop it. So if not started, it means it's stopped. So tell the user that car is already stopped and can't be stopped again. Else started is equal to false. And if it started is equal to false, it means it's not started, and for that matter you can stop it. So go ahead and execute the stop function now and tell them that car stopped. If you press quit, then you break and you're out of it. So let's run it again and see how it's going to work for us. So let's just help. Car starts. Sorry, start the car, stop the car, exit, quit and exit. So let's type starts. The car started and ready to go. Why is it giving me these two commands? Let me check something else. What's happening in the program? Start. Oh. Okay, it's because I have these two lines here. I don't have to see this. Let me check and see what's going on there. If started, car already started, they're ready to go. Else started is equal to true. If started is equal to true, no, car started and ready to go. This shouldn't come here. If command is equal to start, if my command is start, before I can execute that, I need to check. Okay. This is where the problem comes from. Okay, before I can go ahead and execute the start like I did to the stop. Wow, hey, this is serious. So let's just select this. I'm very sorry. Let's just cut it. Control X to cut it here. Let's bring it here. Something like this. Paste it here. If started, then we indent this. Good. Let me check it once more. If we press the start button, before it can execute the start button, it needs to check that the car is started. If it's started, then it should tell you this car already started and cannot start again. So let's clear this. Let's cut this. Control X. So let's move this to the top. Good. I think it should work now. Good. Let's run it again and see what's going to happen now. I think. Let's check help. I'll explain again, please. It's very important. I explain everything to your level of understanding. Okay, let's start it now. Start. Sorry. Car started and ready to go. Let's type start again. Car already started and cannot start again. Good. It's working perfectly. Now let's stop it. I'll explain, please. Car stopped. Okay, let's stop it again. Car already stopped and can be stopped again. The program is working perfectly. That's nice. Good. So now what happened is this. Initially, our program was messing up, right? So we have to fix it. So first of all, let's go through over all the codes again for better understanding. So we set command is equal to empty string. Then we set started is equal to false because initially the car hasn't started, right? So as long as this two statement is true, something has to happen. What's that? We need to prompt the user to enter something. What should the user enter? A command. And if the user enters the command which is help, then it displays the help function. Start means start the car, stop means stop the car, quit means exit. Else, if the user didn't enter help and the user enters start, then we say before we can execute the start function here, we need to check whether the car is started. Something that is already started, how can you start it again? If started, tell the user that car already started and cannot start again. Else, started is equal to what? True. Else means started is not false, it's rather true. So for that matter, you can start the car. So tell them that car started and ready to go. So that is when you can execute it. But if it's already started, tell them this. If it is not started, you can then start it here. Now, what if the user enters stop command? Before we can execute the stop command, we need to check and make sure that the car is not what started. If the car is not started, it means it stopped. Then why didn't you stop it again? It doesn't make sense, right? So, but if it is started, that is when you can stop it. So we say, well, if the command is equal to a stop, then we need to check. So if not started, it means it's already stopped. So they tell the user that car is already stopped and can't be stopped again. Else, started is equal to false. Started is equal to false means it's not it's not started, meaning it's what? It's stopped, right? So tell them that car is what? Stopped. Simple as that. So a leave command equal to quit. It means stop everything, break out of the program, and that's all. Else, if you enter anything aside the four commands above, program should tell you that I don't understand this command. So let's try that option and see where we can enter something like okay, let's type start. Sorry, stop. Initially, let's type stop and see. Car is already stopped and can't be stopped again. Yeah, it's already stopped, so it can't be stopped again. So let's type start now. Sorry, I like this program though. So car started and ready to go, right? So because it stopped, so now that it starts. So let's start it again. Car already started and cannot start again. Let's type a different command like move. I don't understand this command, please. So that is that. Perfect. Program is working. If you give it anything aside its four commands, tells you I don't understand this goddamn command. Now let's check and see the last option. There we have something like say. Is that what? As a developer in a financial institution, write a program which can be used to what? Check affordability and requirement for an applicant, whether. As a developer in financial institution, write a program which can be used to check affordability and requirement of an applicant of a loan. The requirements include must have high income, must have good credit, must not have any criminal record. Please, I think I would have to leave this goddamn program for you to execute, right? Can you do that by yourself? I think you should be able to do it. You can take inputs from the user and make decision, right? Okay, let's do it together. But you can stop the video here and try it by yourself too. You can try that by yourself. So let's move at once and do that, and then yes, we are good to go. That is the final program of ours here. Good. In fact, we are making progress, right? First of all, we have to declare variable call has high income. Then we set it to true. We assume that initially the user has what? High income. We can use if statement, take input and use if statement to do that, but we have already cited examples about that. So I would like us to use this one, which involves Boolean and then the end and then the or operator stuffs for better understanding of those aspects as well. So let's declare that variable. So say has high income, then we set it equal to what? True. So we say has good credit as well. We declare another variable called has good credits. let's check the is equal to let's check the question once again. Must have high income, must have good credit, and then must not have any criminal record. Good. So these are the requirements. So let's proceed. That has good credit is equal to what? True. So we make decision now. Say if let's say has high income and has good credit, then we terminate it here. Then we need to tell them that eligible for a loan, or you are qualified for a loan, something like that. Eligible for a loan. Good. Else prints something like this, not eligible for a loan, something like this. So we are done with the first two requirements. We are going to improve our program a bit. We're going to improve it a bit. So let's check on that. Does not have a criminal record, right? Okay. So good. Now, first of all, we declare variable for has high income. We set it to true. Has good credit. We set it to true. So it means these two requirements must be met before the user can be eligible for a loan, right? So we say if has high income and has good credit, eligible for a loan. So what if one of them is not met? Will the person be eligible for a loan? We talk of what this end operator, and we said both conditions must be true, right? So let's change this on to false and see. Stop it and run it over again. Not eligible for a loan. Why? Because one of the requirements is what? Is false. Have you seen it? One of the requirements is false, which is what? Has high income. It means the person has no high income, and for that matter not. So it means both conditions must be true before the user can be, or the person can be what? Eligible for a loan. So let's set it back to true. Something like this. So now let's check the third requirement, the criminal record. So let's add it to this and see how it's going to be. Has criminal record. Then we set it equal to what? False. So let's check that. So we say if has high income and has good credit, okay. Let's use the while loop here to check something here. Right. So let's do it. Okay. Sorry. Okay. Let's do that. Let me just let me clear this and make decision with that at once. So you say while has criminal record equal to true, sorry, true, something like this. Okay, let me see. Okay, let's check something like let me check. Okay, while not has criminal record, terminate it. Good. So as long as the person has no criminal record, so that is the first condition. So if what's the name? If has high income. Hey, it's not easy. Has high income and has good credits. Then we terminate it here as well. Then we say prints. Eligible for a loan. Simple. Then we say else. Say prints. Not eligible for a loan. Like this. So let's run our program and see. Okay, it's looping. So okay, eligible for a loan, and then we have to break it here. So let's stop it and break it. Then you say break. Okay, let's check it out and see. Eligible for a loan. Good. It's working now. The reason why it's printing repeatedly because it's still looping and it's still checking all these conditions. Meanwhile, it's already true, so it's just repeating. So we need to introduce a break statement to what? After printing the eligible for a loan, it should break that moment. So let's check. So what we are saying is this: if the person has what high income and then has good credits, and then is also not having a good a criminal record, it means you are eligible for a loan, and we've checked and all these conditions are true. So let's check if one of them is false. It's what's going to happen. So let's check this to be false. So let's run it and see. Not eligible. Okay, let's introduce the break this in here as well. So you say break. Good. Let's run it. Not eligible for a loan. Simple as that. So with one condition being, you must meet the three requirements. If one of them is goddamn false, it's not going to be. You are not going to be eligible for a loan. You have to meet these three requirements. So you can see that in this same program, we talk of the break function, the not operator, the end operator, then the while loop. So we combine all this in a simple program. So let's check it once over again. So what? We need to find out whether the person has high income, the person has good credit, and then must not have any criminal record. So initially we declare variables and set this one to be whatever. So you can set them to be whatever and then you check. So for the person to be eligible for a loan, all of them must be true. If one of them is false, you are not going to be eligible for a loan. So simple as that. So I say thank you very much for watching, and then you can try those expressing this algorithm in this same program yourself over and over and over again, and then make sure that you understand them perfectly before we proceed. And then our next lesson, we're going to look at functions, and then from there we proceed and begin looking at how to create our real world applications with GUI and without GUI. As for our what do you call it, the text to speech and all that, they need a very strong network, so we need to have that in mind and make sure that even if where we find ourselves during the introduction of that lesson, the network is not good, you can still hold on. You can just watch it and then understand how it works. When you get to a very good network place, you try it by yourself, and from there everything will be good to go. So I think thank you very much for watching, and then bye for now. I'll be leaving the file containing the algorithms we just expressed on the Telegram channel, so you can just take it up, follow them, and then try expressing them here. Try playing with the codes just as you saw us doing here and there, and that is what will make you master Python programming. So thank you very much for watching, and then bye for now.